Hi everyone, welcome back to Learn IT with Venkat. Today's video I am going to discuss with you the easiest and simplest way of doing VLSM for the local area network. VLSM stands for Variable Length Subnet Mask. As name implies, it uses more than one mask in the same network, which means it allows all subnet masks of the VLANs to have variable network sizes. For example, if you have 5 VLANs, each VLANs will have different IP requirements. So all VLANs will have different subnet mask and network bits. So by using this technique, the usability of subnets are increased and it efficiently uses the address space by reducing the IP address wastages. We will see how to do it with simple example. Here we go. VLSM stands for Variable Length Subnet Mask. Here we have our chart for these calculations. 4 actors here and its bits positions, values here and its total at the top. Given IP address is 172.16.0.0/16, which is a class B IP address, and this IP address is given to the administrator with the below requirements for local area network. The requirements are 5 networks, 10, 20, 30, 40 and 99 for management, and each network has different IP requirements. Here you can see VLAN 10, 20 needs 200 IP addresses and 30 needs 100 IP addresses and 40 needs 50 IP addresses and VLAN 99 needs 10 IP addresses. So each network will have different subnet mask because of different IP requirements here. That's why it is called as variable length subnet mask. We will do one by one. First we will start with VLAN 10 and 20, which needs 200 IP addresses. So here for VLAN 10 and 20, the given IP address is 172.16.0.0/16 network bits. This network needs at first 200 IP addresses for the VLANs 10 and 20. So for 200 IP address, just look at the chart. So 2 to the power of what we will get 200. So 2 to the power of 7 is 128. So if you go to 2 to the power of 8 next value, you will get 128 plus 128 256. So 2 power 8 will have 256 minus 2 IP address you have to remove. One for network ID and another one for broadcast ID it will go. You can't use it for host person. So remaining you will have 254 IP addresses. You can use it for host person. So here you need 8 bits enough to get 254 IP address. In the given IP address we have 16 plus 16, this 16 for network and this 16 for host person actually, but for host we need 8 bits. So I am going to divide this 8 and keep that 8 for host, and remaining 8 I am giving it to the network bits. So 16 plus 8 now. So 172.16.0.0/16 plus 8 is 24 bits now. Because 8 bits I hold for 254 IPs. 8 bits is enough. So remaining bits I am giving it to the network bits. So this 8 given to the 16 bits. So together we called 24. That 8 bits for host. Hope you understand. So for this subnet mask, once you find out the network bits, just look at the table 24 and at the top 255 in the third octet. So 255 first octet full, second octet full 255 point, third octet also 255 because 24 bits. So at the top it is having value 255 in the third octet. So 255 255 255.0 is the subnet mask. Now we have to compute network ID, first host ID, last host ID and broadcast ID. These are all the parameters required for the networks. So first network is your given IP address 172.16.0.0/ now 24 bits. So first ID obviously 172.16.0.1. If you want the last host ID, you have to compute the next network. So how we can compute the next network? Look at the table 24, inside the table 1. So in the third octet 1 is the value. So 172.16 third octet 1.0/24. So because 24, look at the table, 1 in the third octet. So previous to that 172.16, so 1 is the next network, so before it should be 0 and 0.254 is the last host, and 172.16 0.255 is the broadcast. So if you look at this range 0.1 to 0.254, so totally you have 254 IP address in this network. Now you could understand. So next network, first host ID 172.16.1.1, and here for last host IP address we have to go for the next network. As I said before, if it starts with 1, then it will be compute 1 plus 1 plus 1 plus 1. So whatever the value it starts, plus of that value is going to be. So now 2.0/24. So last host here 1.254, broadcast is 1.255. So this is for VLAN 10 and this is for VLAN 20. And if you look at this range is also, you will get both the network will have 254 IP addresses. This network I am giving it to VLAN 30. Next we will do for VLAN 30 network. So this is the IP which we received it before, and for VLAN 30 we need 100 IPs. So look at the table again. So 2 to the power of 7 we will get 128 minus 2 IP address, you will not use it for host person. So 126 IPs you can compute. So 2 IP address, one for network and another one for broadcast ID it will go. So you will get 126 IP address from 7 bits. So 7 bits enough for getting 126 IPs. If you look at the given IP address, network bits is 24, plus we have 8 bits for host so far, but 7 bits is enough. So I am taking 7 reserved for current scenario and 1 I am giving it to the network bits. So 24 plus 1 become 25 is my network bits. So 172.16.2.0/25. Hope you understand. 7 bits is enough to compute 126. So already I am having 8 bits for host. Needed is only 7. So remaining 1 I am giving it to the network bits. So 24 plus 1, 25. Subnet mask. So again look at the chart. Where is 25? 25 is in the 4th octet. And look at the top, 128 in the 4th octet. So 3 octets full. So 255, 255, 255 point 4th octet 128. Clear? Now network ID, first host ID, last host ID and broadcast ID. So network ID is the given IP address 172.16.2.0/25, and first host IP address is 172.16.2.1. Last host you have to compute the next network. So 172.16.2. Look at the 25 and inside the table you have 128. So 2.128/25 is the next network because here 128. So last host IP address for the first network 172.16.2. Here 128. So here 126 is the last and 127 is the broadcast. So 172.16.2.127 because next network starts with 128. So if you look at the IP here 2.1 to 2.126, which is this 126 IP address you are getting. This is for VLAN 30, and the next network should be given to VLAN 40. So VLAN 40 needs 50 IP addresses. So here the same job for getting 50. How many bits needed for host? Look at the table again. So 2 to the power of 6 is 64 minus 2, we will get 62 IP addresses. So for that we need only 6 bits enough for host for getting 62 IP addresses. If you look at the given IP's network bits, 25 for network and 7 already for host. But here we need only 6 bits So I am holding the 6 bits and 1 I am giving it to the network. So 25 plus 1, now network bits become 26. 172.16.2.128/26 now. Subnet mask. So network bits is 26. Just look at the table where the 26 is in the 4th octet. Top 192 in the 4th octet. So 255 first octet full, second octet full, third octet full. In the 4th octet 192. So here 192. So this is my subnet mask for this network. Network ID, first host ID, last host ID and broadcast ID we have to calculate. First network is the given network ID 172.16.2.128/26 now. Then first host is going to be 172.16.2.129. For last host we have to compute the next network. So 26, if you look at inside 64. But here look at 172.16.2.128 is already there. But if you look at the chart, here the changes is from 64 in the 4th octet. Suppose if you write 172.16.2.64, this is not possible because already the previous network is 128. So obviously next network should be more than that. So we have to calculate 64 is the various change. So 64 plus 64 we have to compute until we get the next highest value. So for that 192 is the next highest value. So next network is 172.16.2.192. Hope you understand. Because 128 is already there, 64 we can't take it. So 64 is the changes. So 64 plus 64 128 plus 64 192, which is greater than 128. So I am taking that network as my next network. So last host here 172.16.2.190 is the last host. And 172.16.2.191 is the broadcast. So if you look at this range 2.129 to 2.190, you will get 62 IPs as per the calculation. So here 26, this would be given for the VLAN 99, and this is going to be for VLAN 40. So this is the IP we received it for VLAN 99, which needs 10 IP addresses. So here is the chart. For 10, 2 to the power of 4 we have to take. So 2 to the power of 4 equal to 16 minus 2. So we will get 14 IP addresses. So how many bits here is enough? 4 bits enough for getting 14 IP addresses. So given network bits is 26, plus we have 6 hosts, but we need only 4 bits. So remaining 2 bits I am giving it to the network. So 26 plus 2, now it become 28 network bits. So 172.16.2.192/28. The subnet mask for this network 28 is in the 4th octet. Look at the top, 240 is the subnet mask. So 255.240 is the subnet mask. So network ID, first host ID, last host ID and broadcast ID we have to calculate. So first network is going to be 172.16.2.192/28 already. First host IP 172.16.2.193. If you want to get the last host, you have to compute the next network. So 28, look at the table 16. Like before, here also you can see 172.16.2.192 is the previous network. But if you look at the table here in the 4th octet, 16 is the change, which is not possible because already the previous network is 192, which is greater than that. So you can't simply substitute 16 here. So you have to divide that 192 by 16, or you can do 16 plus 16 plus 16 plus 16. That like that also you can go until you get the value greater than 192, or you can do like this, 192 divided by 16 you can put. So if you put like this, the value you will get is 12. So equally divided, no fractional numbers. So 192 plus 16 you can add it. So if you add like this, you will get 208. So the next network is 172.16.2.208. Suppose if you are not getting decimal values, you have to take the next value to compute it. So last host IP address is 172.16.2. So 208 is the next network. So for last host 206 is the last host IP, and 172.16.2.207 is the broadcast IP. So if you look at this range, 193 to 206, you will get 14 IP addresses in this network. So this is for VLAN 99. So all the networks we have computed the IP addresses. So now I am going to draw the table for all the VLANs: number, network ID, first host ID, last host ID, broadcast ID, and subnet mask. So these details I have to plot it here. So VLAN 10, for VLAN 20, for VLAN 30, for VLAN 40, and for VLAN 99. So this is the addressing table for the given requirements. If you want to understand the chart, you can refer my previous video. The link is given in the descriptions also. Hope you understand. Thanks for watching. If you like this video, share with your friends and subscribe this channel for getting more video updates. Bye bye.